Okay, guys, a few people have asked me about solutions to the NHT Northern Hemisphere Exam 1 for this year, 2018, because they're not up on the website, so I thought I'd run through them quickly, make a video so you know exactly what to do. I will run through everything showing all working, as painful as it is. Okay, first question, I've got a quotient rule question. U is my numerator, e to the x. U dash is also e to the x. V my denominator, x squared minus 3. V dash is 2x. We know that f dash x is v times u dash, e to the x squared minus 3 minus u times v dash, e to the x, 2x, over v squared, which is x squared minus 3 squared. You could leave it like that. I'm sure you get full marks. However, we can also take out e to the x. We've got x squared minus 2x minus 3 on x squared minus 3 squared. Okay, we've got a product rule question. So u is x plus 5, u dash is 1, v is log e x, v dash is 1 on x. dy dx is v times u dash, log e x, plus u times v dash, which is x plus 5 on x. dy dx, given x is 5, is log e 5 plus, I've got 5 plus 5, which is 10, on 5, which is 2. So log e 5 plus 2. Okay, I've got f of x is negative x squared plus x plus 4. G of x is x squared minus 2. F of x is therefore, I want to find f of 3 first, because I'm going to find a g of f of 3. So f of 3 is negative 9 plus 3 plus 4, which is negative 2. So g of negative 2, because that's f of 3, is negative 2 squared minus 2, which is 2. All looks good to me. Okay, express f of g of x in the form ax to the 4 plus bx squared plus c. So f of g of x, so f of x squared minus 2, which means wherever we've got an x, we replace it with an x squared minus 2, plus x squared minus 2, plus 4, negative x to the 4 minus 4x squared, plus 4, plus x squared, minus 2 plus 4 is plus 2. So we're going to get negative x to the 4, plus 4x squared, plus x squared, which is plus 5x squared, minus 4 plus 2, minus 2. They're all integers, minus x to the 4 plus 5x squared. It doesn't say we have to give a, b, and c. It just says put it in that form, which it is in that form. Okay, integral of e to the x minus e to the negative x, 0, 1, e to the x minus e to the negative x dx. When we integrate e to the x, we know we just get e to the x. When we integrate e to the negative x, we've got to divide by the negative. So we get plus e to the negative x between 1 and 0. We know when we sub 1 in, we get e to the 1 plus e to the negative 1 minus e to the 0 plus e to the 0. Of course, that's 2. So we end up with e plus 1 on e minus 2. Or we could say 1 on e out the front. We're going to get e squared minus 2e plus 1. Either of those would be fine. Okay, we've got log 3 of t minus log 3 of t squared minus 4 is equal to -1. Of course, when we subtract, we divide with our logs. So we can say log 3 of t squared minus 4 on, I stuffed that up. T on t squared minus 4 is equal to -1. So we get t on t squared minus 4 is equal to 3 to the -1, which is equal to 1/3. So let's cross multiply. We're going to get 3t is equal to t squared minus 4. So t squared minus 3t minus 4 equals 0. T minus 3, t minus 4. T plus 1 is equal to 0. Therefore, t is equal to 4, or t is equal to -1. However, t has to be greater than 0, as we can't log negatives. So therefore, t equals 4. If that would be okay in this equation, actually no, it wouldn't, because I'd get t squared, which is 1 minus 4. We can't log negatives. So our only solution is t equals 4. Okay, state the range of this function. This function is only defined from 0 to infinity. Let's do a quick sketch. We've got an asymptote at -2. We've got an asymptote at -3. It starts at 0, so I put 0 and I get 3.5 minus 3, which is a half. So it starts at y equals a half, and it's a hyperbola, so it's going to go down. Okay, so my range, h is an element. My lowest value is -3, but it's not included because it's an asymptote. My highest value is a half, and that is included because 0 is included. So our range is from -3 to a half. Find the rule for the inverse. So I'm going to say swap x and y. So we're going to get x equals 7 on y plus 2 minus 3. X plus 3 is equal to 7 on y plus 2. Y plus 2 is equal to 7 on x plus 3. Therefore, h inverse of x is equal to 7 on x plus 3 minus 2. It doesn't say to state the domain. However, just to be safe, to get full marks, x is an element of -3 to 1/2, because our domain of our inverse is our range of our original function. Okay, discrete random variable. So it's a discrete random variable, so let's make a table, just to make it easier. What values have we got? 0, 1, 3, 4, 6. 1, 3, 4, 6. 0, 1, 3, 4, 6. Okay, so that's x, the probability that x equals x. Show that k equals 12. Okay, so when I sub 1 in, I get k. When I sub 4 in, I get 4k. When I sub 6 in, I get 6k. When I sub 3 in, I just get k. And I get 0 otherwise, so that has to equal 1. So 12k equals 1. Therefore, k is equal to 1/12, as required. 2 marks. Well, it's a bit weird. Okay, find e of x. So we know what k is now. So that probability is 0. When x equals 3, our probability is k, which is 1/12. When x equals 3, when x equals 1, our probability is k times x. and k is 1/12, so 1/12 times 1, which is 1/12. When it's 3, it is k, so that's 1/12. When it's 4, it's 4 times 1/12, which is 4/12. And when it's 6, it's 6 times 1/12, which is 6/12. And that makes sense because if we add across, we get 12/12. Now, our expected value is x times the probability of x, the sum of x times the probability of x. So 0 times 0, 1 times 12, so 1/12. 3 times 1/12, 3/12. 4 times 4/12, 16/12. 6 times 6/12, 36/12. So we're going to get 56/12. Divide them both by 4. 14 on 3. That's our expected value. The probability that x is greater than or equal to 3, given that x is greater than or equal to 2. Greater than or equal to 3, given that x is greater than or equal to 2. If it's greater than or equal to 2, it also has to be greater than or equal to 3 because it can't equal 2. So that's just 1 because it has to occur. If it's greater than or equal to 2, then it also has to be greater than or equal to 3 because it doesn't equal 2. It's a bit tricky, so that's just 1. Oh, 9 marks. Okay. Our function is defined from 0 to pi on 2, 4 cos x. Okay, so this is f of x. It's cos graph, so it starts at the top, goes through pi on 2. We know when x is pi on 4, cos of pi on 4 is 1 on root 2, which is about 0.7. So if I times that by 4, I get 2.8. So 2.8, let's say it's about there. So this is my graph of f of x. Let's change colors. 3 sine x, so sine starts at the bottom. It's going to finish at 3. 3 times 0.7 is 2.1. So it's going to look something like that. So that's g of x. Okay, let c but be such that f of c equals g of c, and c is between 0 and pi on 2. So what does that mean? It's basically this point here because we want them to be equal. So that value must be c. Okay, so f of c, so 3 sine c is equal to 4 cos c. Let's divide both sides by cos of c. We get sine c on cos of c is equal to, I'm going to divide the 3 across the other side, 4 on 3. We know that sine on cos is tan of c, so tan of c is 4/3. If we know tan of c is 4/3, let's say there's c, tan is opposite over adjacent. This must be 5 because it's a 3, 4, 5 triangle. It says to find sine of c and cos of c, so sine is opposite over hypotenuse. Sine of c is 4 on 5. Cos of c is adjacent over hypotenuse, 3 on 5. So there's sine of c and cos of c. Let A be the region enclosed by the horizontal axis, the graph of f, the graph of g. Shade the region A on the axis provided in part A and also label the position of C on the horizontal axis. I already did the position of C. So this region in here, that's nice for a freebie mark. So that is the area, was it A? The region A. So that's A. Okay, so we're going to break it down. We're going to have this area, which is g of x, which is 3 sine x. Okay, so the area A is from 0 to c of 3 sine x dx plus from c to pi on 2 4 cos x dx. Okay, if we integrate sine x, we're going to get negative cos x, so negative 3 cos of x between 0 and, because I'm going to substitute into cos, I'm going to get c, we can say here, c is equal to cos inverse of 3 on 5, and here we can say c is equal to sine inverse of 4 on 5. Now they're going to help us down here. So instead of having c, I'm going to put cos inverse of 3 on 5 plus, when I integrate 4 cos x, I get 4 sin x. And this time I'm going to replace c with sine inverse of 4 on 5. Because when I sub it in, sine inverse, they cancel each other out. And then pi on 2. Okay, so if I put cos inverse of 3 on 5 into cos of x, I'm going to get negative 3 times 3 on 5 minus negative 3 times 1, because cos of 0 is 1. That's our first one done. Plus 4 sine of pi on 2. Sine of pi on 2 is 1, so I get 4 times 1 minus 4 times sine of sine inverse 4 on 5 is 4 on 5. Okay, so now we clean up. So I get negative 9 on 5 plus 3 plus 4 minus 16 on 5, which is 7 minus 25 on 5, 7 minus 5, which is 2 square units. So that's what that area in there is. Okay, that was a bit tricky. Okay, let P hat be the random variable that represents a sample proportion of customers who bring their own shopping bags in a large shopping centre. From a sample consisting of all customers on a particular day, and approximately 95% confidence interval, the proportion of customers who bring their shopping bag to this large shopping centre was determined to be that. Find the value of P hat that was used to obtain this. Okay, so we know that P hat plus or minus 1.96 standard deviations would give us this interval. So our value is halfway between 4853 and 5147, which is P hat is 5,000 on 50,000, which is 1 on 10. Okay, use the fact that 1.96 is 49 on 25 to obtain the sample size of this approximate 95% confidence interval. Okay, so our error is how far we go off the mean. So if I go from 5,000 on 50,000 to 5,147 on 50,000. So my error is 147 on 50,000. That's equal to 49 on 25 square root P 1 on 10 times 9 on 10 over square root n. Okay, something's got to go. That 49 will divide into that 3 times. If I put the 25 on top, I get 75 on 50,000 is equal to square root 9 on 100, 9 on 100 n. Okay, so if we divide through by 25, I'm going to get 3 on 2,000. Yep. Okay, if we square both sides, I'm going to get 9 on 2,000 squared is equal to 9 on 100 divided by n. Okay, so let's multiply the n to the other side. Let's divide the 9 to the other side. So I'd get those 9s cancel, and I'd get 2,000 squared on 100. So it's going to be 4, 1, 2, 3, 1, 2, 3 on 100. So knock off a couple of zeros. So my sample size was 40,000. So 40,000 people gave us that 95% confidence interval. Makes sense that it's got to be a huge number because the error is really small, 147 on 50,000. So if it's a 95% confidence interval, then the sample size must have been huge. Okay, how many questions have we got left? We're nearly there. Where does it start? The area shows a trapezium with the vertices 0, 0, 0, 2, 3, 2, and B0. On the same set of axes as the trapezium, part of the graph of a cubic polynomial is drawn. It has a rule, ax, x minus b squared. So we know that's b naught. A is a non-zero real number, and 0 is less than x, which is less than b. Okay, at the local maximum of the graph, y equals b. Find a in terms of b. So we know y is equal to ax, x squared minus 2bx plus b squared, which is ax cubed minus 2abx plus ab squared x. Okay, so there's a local maximum when y equals b. So let's say dy dx is equal to 3ax minus, what's a squared? 4abx plus ab squared. When dy dx equals 0, we know that y equals b. So if we let this equal 0, what are we going to get? Let's take out an x. So x, 3a minus 4ab equals negative ab squared. So we're going to get x is equal to negative ab squared on 3a minus 4ab, which we can make positive by saying ab squared on 4ab minus 3a. Now we can take out a as a common factor. So get ab squared on a, 4b minus 3. They'll cancel, so I get b squared on 4b minus 3. Then we know when we sub this into this equation, we end up with, what do we end up with? We end up with y equals b. So b equals a times x, so a b squared on 4b minus 3, and then x, so b squared minus, this is pretty ugly. I haven't stuffed anything up, have I? Suppose it is the last question. Okay, so that's our value of the turning point, b squared on 4b minus 3. What's it easier to put it back into? Is it easier to put it back into this? Let's go with what we're doing before. So a times x, a times b squared on 4b minus 3, b squared on 4b minus 3 minus b all squared. Okay, can we clean that up? B, let's put that 4b minus 3 on b squared, and that's equal to a. Let's try and clean this up. So if I have b squared on 4b minus 3 minus, if I put it on 4b minus 3, I get b 4b minus 3. Okay. This doesn't look very nice at all. I think it's a better option than the other one, though. Okay. Okay, so from here, we get that cancels with that. Over here, we get 4b minus 3 on b is equal to a. B squared minus 4b squared, which is minus 3b squared. And then, is it minus 3b? Plus 3b. Plus 3b. On 4b minus 3, all squared. Okay. So a would be equal to this, when I bring it across the other side, 4b minus 3 cubed on I'm going to take out 9, 3 and 3. Let's take out negative 3. So I'd have 9b cubed, because if I take it out of this, I have to square it, because when I bring it back in, I've got to square root it. Yep. So 9b squared, I've taken out a negative 3, so I'm going to have b minus 3 on the bottom. That's pretty ugly. I can't see anything else we can do with that. Unless I'll stuff something up. So y equals dy dx equals 0, y equals b. Dy dx equals 0. Everything looks right from what I can see. That looks right, that looks right, that looks right. Okay, so we'll take it as a is 4b minus 3 cubed on 9b cubed, b minus 3. Is that all else for a in terms of b? The area between the graph of the function and the x-axis is removed from the trapezium as shown in the detail. Oh yeah. Show that the expression for the area of the shaded region is... Okay, so what do we know? We know that's 2. We know that that length is b, and that that length is 3. So have we found the big area? So the area would be 1/2 top plus bottom, 3 plus b times my height, which is 2, minus from 0 to b, my function, which is ax, x minus b squared, so it would be ax, x minus b squared, but we know what a is. So we'll say ax cubed minus 2ab x squared plus ab squared x. Oops. So ax cubed plus minus 2ab x squared and then plus ab squared x dx. Okay, so here they're going to cancel. So I'm going to have b plus 3 minus, let's have a look at this. I'm going to have ax to the 4 on 4 minus 2ab x cubed on 3 plus ab squared x squared on 2 between b and 0, which we know is b plus 3. This will be the decider if it works or not. ab to the 4 on 4 minus 2ab to the 4 on 3 plus ab to the 4 on 2 minus 0, because they've all got x's in them, so that's going to be 0. Okay, so let's get this on a common denominator. I'm going to have b plus 3. What are we going to get there? Minus, that's going to be an 12. So 3ab to the 4, 12, 8ab to the 4, 12, 6ab to the 4. So I've got 3 plus 6. I've got ab to the 4 on 12. Okay, so we have stuffed up something before. Because if a is that, that looks nothing like that. What would a need to be? A would need to be 9 on let me think. AB b to the 4 on 12 equals 9b squared on 16. So we multiply that across, we're going to get a equals that 12. It's going to be 3, 4, 27 on 4b squared. Okay, what have we stuffed up back here? When dy dx equals 0, y equals b. Local maximum of the graph, y equals b. So we got dy dx, if I expanded it correctly, ax x squared minus 2bx plus b squared. Ax cubed minus 2ab x squared plus ab squared x. When I derive that, I get 3ax squared. Maybe they wanted us to use the product rule. It might work out nicer. So let's scrap this. Let's scrap all of it and start again. This is why you need extra time at the end of an exam. And sometimes it's not super easy. Hopefully we can still ace it though. Okay, if I said dy dx is derive ax, I get a x minus b squared. Derive x minus b squared. I bring a 2 down to the front. I'd have ax x minus b, which we know, if we let that equal 0, we can take out x minus b as a common factor, and then we're going to have, I should write it just so we know. So let dy dx equals 0 for stationary point. Okay, so we're going to take out x minus b. We're going to have ax minus ab. That's that done. I've taken out x minus b, so I've got plus 2ax, and that equals 0. So from here, x equals b, which is this point here. From this one, we're going to get 3ax minus ab equals 0. So we're going to get x equals ab on 3a, which is b on 3. Now that's much nicer than what we had before. Okay, if x equals b on 3, when we sub b on 3 into the original equation, so a times b on 3. So we know when x equals b on 3, y is equal to b. So I can put that into the equation. A times b on 3 times b on 3 minus b squared equals b. Okay, so now we've got to clean this up. So a, b on 3 minus 3b on 3 minus 2b on 3 squared is equal to b. Okay, so what are we going to get? We're going to get a. If I square the top, I get 4b squared times b, 4b cubed on 9 equals b. So therefore a equals 9b on 4b cubed, which is 9 on 4b squared, which is what we needed. Oh, 27. Oh, I forgot to square. So down here, that's going to be 9. That's going to be 27. And then that's going to be 27 on 4b squared, which is what we get down here. So b plus 3 minus 27 on 4b squared times b to the 4 on 12. Don't let people know that we cheated there. We didn't cheat, we just used our brains. Okay, they cross out, I get a 2. That goes 4 times. That goes 9. So b plus 3 minus 9b squared on 16 square units. Okay, find the value of b for which the area of the shaded region is a maximum. Find this maximum area. Okay, so we've got, what did we call it? Expression for the shaded region. So we're going to say a of b is b plus, let's say, negative 9b squared on 16 plus b plus 3. Now we know this is a maximum graph because it's a negative b squared. Find this maximum. Okay, so a dash of b is negative 9 on 8b plus 1. A dash of b equals 0 for max slash min. Okay, so I get negative 9 on 8b plus 1 equals 0. So we bring that to the other side, we're going to get 9 on 8b is equal to 1. So b equals 8 on 9. The area itself, okay, so we get negative 9 on 16 times 8 on 9 squared plus 8 on 9 plus 3. Okay, so I've got negative 9 times 8 times 8 over 16 times 9 times 9. So that will cancel with that and make it a 2. That will cancel with that and make it a 1. So I get, that will cancel with that. I get negative 4 on 9 plus 8 on 9 plus 27 on 9, which gives me 31 on 9. Therefore, max area is 31 on 9 when b is equal to 8 on 9. Hopefully we have just aced this exam. If not, I'm annoyed because I made a stupid error somewhere. Okay, cool. Well, hopefully you've learned something from this, including when you stuff up, how to fix it up if you can. Not everyone's perfect. Obviously I wasn't then, but I was able to reverse engineer my solution and realize that they wanted us to use the product rule here, which just made the whole thing so much easier. Okay, good luck in the exam. Hopefully this has helped you out. Bye.